As students engage with a PhET simulation, their exploration can be quite rich and varied. What are some things a teacher might want to pay attention to as they walk around the class?
I'm pretty careful not to always be in the front of the room. I move around a lot.
It's kind of tiring. People underestimate sometimes how easy lecturing is. When you've got them kind of working on their own, every little group is a little bit different.
Teachers can be doing several different things while circulating the classroom. Shopping for examples, keeping track of progress, helping students get unstuck, and helping groups to work productively. While you're eavesdropping on student conversations, you can listen and watch for ideas and examples that you can use in later discussions. For example, in gravity and orbits, you could watch for students experimenting with the placement of the planet. Then, as part of a later discussion, you can ask those students to share what happens to the planet's motion when it is closer or further from the sun.
Either hold on to it for a later discussion or to address it as a whole table with the students, because one student's realization is awesome for other students to then also make that same connection.
I might say something like, wow, so I just found that Jose was able to make a planet have a revolution in just 36 days. I wonder how he did that. And then all of a sudden you have 20 other students who are trying so hard to beat that 36-day mark.
Circulating also gives you a chance to learn where students or groups are at in the activity, their overall progress, as well as their understanding of the concepts and ideas.
I listen to their conversations. Are they having aha moments?
And are they recording and reflecting on what they've just learned?
One thing that you would want to watch out for is that they still are actually recording their findings on their activity page.
Are their conversations or investigations carrying them too far from the learning goals?
Are they changing things? Are they working on answering the questions? Does it look like they're getting the answers? Are they on the right track?
Or if you notice that they're done with a section, it might be time to prompt them to move on. While circulating the classroom, teachers can simultaneously pay attention to student difficulties at the individual level, while also having a bird's eye view of the class as a whole.
I found the easiest way to do that is really just identify beforehand those particular questions that I'm going to look for mastery.
Teachers can then decide whether to intervene with a student individually or address the whole class. See our separate video on Checks for Understanding for more ideas on monitoring students' progress during a PhET activity. While you're circulating, keep an eye out for students who are struggling with the content or having trouble using the simulation.
I think part of the comfort my students get with feeling like they can use the sim and learn on their own is they know that I'm around to help them if I need to. I go around, I don't give them the answer, but I'll probe them. Well, how do you think you might do this?
Here are several strategies for helping students move forward while allowing them to be in control of their own learning.
I'll say, well, what have you tried? And I let them show me what they've tried. Or I'll say, did you find that tool useful? If you didn't, you might want to close it.
I try to step back and just listen to them and not butt in unless I feel like they're really starting to flounder. So it's more just trying to give them space.
If you notice that a group is stuck on something, ask them to check in with another group who has already figured it out. Or you might pose their question to the entire class, or encourage students to help each other within their small groups.
If they're sitting next to a group that's having problems, I say, how did you do this? And to listen in on that, to hear how they help each other, which is just heartening.
Here are some examples of prompts teachers have found effective in helping students get unstuck.
One of the things that I've noticed that's really helpful if students are stuck on one part of the sim is to say, I wonder. So I wonder what would happen if you did this.
Okay, so what is that? What's going on here? What is this like that you've seen in the real world? Oh, what do you think would happen if you move this?
How do you know that? Or why does that make sense?
If I see that a student wrote something down that probably shouldn't be happening in the simulation, it's just a really easy thing to say, oh, so you found that this happened in the simulation. Can you show me that? And then the student will show you it, and then as they're doing it, they realize, oh, I actually checked increase when I should have checked decrease.
Check to see if students are working together productively. But how do you know if students are engaged?
When a simulation is working really well in the classroom, we see the students doing a number of things, talking to their partners, trying out different mini experiments with the simulations, asking the teacher conceptual questions, and really participating.
You didn't have a white screen, you had like a yellow screen or something. Would that still be additive?
Yeah, it's subtract.
We also see students really eager to share the ideas that they've figured out from the simulations with their classmates, or go up to the board and show the rest of the class what they've figured out.
If students don't seem engaged, you might try some open-ended prompts, as described earlier in this video. But if students seem consistently disengaged, you might rethink how your activities are designed. Activities that pose challenges for students, without being overly prescriptive, are more likely to get students involved in inquiry.
Don't so much just provide like a series of steps, like do this here, do this here, do this here, but really allow the students to have an opportunity to explore for themselves and to figure things out.
For more ideas, see our separate video on designing activities with PhET. Sometimes students can get off track. For example, in the gas properties simulation, students may keep filling the container with gas to watch it explode, just for the fun of it.
But I'll just come around and say, okay, wow, that's really cool. What do you think is going on there? What's causing that? And try to direct it back to what they're supposed to be working on.
Lastly, you may need to manage some group dynamics. If, for example, a student is dominating the computer, you might consider rearranging a group, which can help students change their patterns of interaction, or assign rotating roles so that each member gets a chance to be in charge of the simulation or activity sheet. So to recap, there are several things a teacher can do while walking around the classroom. A teacher might be shopping for examples of what students can do or discover with the simulation to bring up with the whole class. Keeping track of students' progress individually and as a whole class through the activity. Helping students out without taking over by showing ideas from other students and using open-ended prompts that help students figure it out on their own. And helping students work productively in their groups by checking to see if they're engaged and on task.
There's definitely a lot of talking when the simulation is going on. I would say the most common comments are probably, look at this, look what I did, or how did you get it to do that?
You are discussing what you're seeing and what's happening, and then we got to explore on our own and draw conclusions from that experience.